Well, we're back, and now we're talking about ecology. And ecology is going to be quite a shift from what we've been talking about before, because ecology is more about, and some students tend to really gravitate toward ecology because it's more about things that you already know. And if you're the kind of person that likes to be immersed in nature or loves animals, you might especially gravitate toward ecology. So we're going to just do an introduction today. Next lecture is going to be more on the population aspect of ecology. But for this one, we're just going to focus just on the introduction of it. So let's go ahead and let's get the show started. All right, so let's talk first about the definition of ecology. And ecology is really the study of macroscopic life, mainly. I mean, we do talk about some microscopic life, but the focus really is on organisms and how they interact with their environment. So really, it's the study of how organisms interact with their environment. So many examples I can tell you. So anytime that you see anything living doing anything in the environment, that is the study of ecology. You could see a squirrel climbing a tree. Well, why is it climbing that tree? Well, it's interacting with the environment. It is doing something in the environment, and the squirrel obviously has a rhyme and reason why it's doing so, and that is up to people to study. Whenever we talk about a school, think back all the times in elementary school, middle school, high school, when you talk about, I don't know, why a bear scratches their back against a tree. Well, that's because somebody studied it. Things that we take as mundane really have been well studied throughout the years by ecologists. So really, the idea of ecology is to learn how different organisms interact with their environment, including plants too. One thing, I don't know if we'll talk about it in this class. If you take more of a class like about BioM01, we talk about how grass, and this one's interesting. Whenever grass is damaged, it actually secretes some chemical signals that calls over certain insects. And the idea behind it is that grass, well, before the advent of the lawnmower, whenever grass was damaged by something like a caterpillar, of course, the grass just doesn't want the caterpillar to go open season on it. So it actually secretes these chemical signals that, if I remember correctly, calls over wasps. And the wasps come and lay their eggs in the caterpillar, which then kills it. And that's why when you cut grass, there's that freshly cut grass smell. It's actually a smell of, well, if you think about it, you're bringing death upon caterpillars that may or may not be there. Well, after the lawnmower, I would bet on not many caterpillars being there, for reasons I don't think I need to say. But those are just some really cool things that you can discover with ecology. When I was in college, I attended a talk, a very interesting talk actually, and this talk was about this group of ecologists, how they were trying to analyze the mating habits of squirrels in some forest. I know that it was more in depth than that, but that's all I remember. One of the few talks I had to attend that I did not fall asleep in. And we all thought it was kind of funny because they actually built a fake squirrel, and this was a semi-mechanical squirrel. How it worked is that they could alter how it wagged its tail, and then they would record how the squirrel responded to the different tail wags. And I thought that was super cool. I don't know how the research concluded, but with ecology, it's lots of stuff that you do out in the field. There's not too much lab stuff that you do with ecology. And with ecology, you're going to include the larger world. And this includes the biosphere. So ecology is not in a lab. It is not in a petri dish. It is in the world. We call this the biosphere, and this contains everything living and non-living. Contains living and non-living components. Now, whenever in ecology, well, in general, whenever we talk about something living, we use the term biotic. And biotic just means alive or once alive. I know that's not a very scientific definition, but that's basically what it means. It's either living or it was at one time living. So anything that is biotic, things like, for example, trees, bushes, ivy, dogs, cats, well, waste, decomposing matter, apples from the supermarket. So those are examples of things that are biotic. Now, as far as abiotic goes, that of course is the opposite. And abiotic means that it is, well, not living. So never living, non-organic. And I know, once again, that is not entirely scientific, but things that are abiotic, to give you some examples: rocks, water, dirt, not soil. Soil is partly biotic, but I'm talking dirt like sand. Also, things that you may not consider: sunlight, wind, temperature. Those are all considered abiotic components, and they go hand in hand. For example, abiotic conditions determines the presence of biotic conditions. If you don't have rain, then you won't have plants. If you don't have fertile soil, you won't have worms in the soil. So biotic and abiotic components, they have a very integral relationship. And these two components, biotic and abiotic components, they make up the biosphere. And speaking of that, we're going to talk about weather. And weather is the current conditions. So weather is the current conditions in an area. Now, these conditions include the following: temperature, winds, precipitation or rain. I know precipitation isn't commonly used, so if you're not sure, that means rain. And also humidity. Some people also include cloud cover, so will I. So cloud cover. But these are the conditions right now. In fact, let's go ahead and let's just look and see what the current weather is. So I'm going to look up the weather in Thousand Oaks. So weather Thousand Oaks. And I know you're probably saying, well, professor, this is groundbreaking. You're teaching us how to search for the weather. Well, you know what? It's an essential skill. Like, what if you decide that you want to leave Ventura County and you just spur of the moment you want to go to Utah? Knowing how to Google the weather can get you far. Make sure you don't drive up in a snowstorm or something like that. I have a surprising number of high school students going to college in Utah. And it's interesting because when I was younger, Utah was considered basically like a punishment. But I guess now it's become an area that's more up and coming. I know a lot of my students are excited about it. It is definitely beautiful there, though, especially if you go up into the mountains. I digress. Okay, so anyways, right now it's Sunday, and it's pretty close to 11 o'clock. And if we look here, it's currently 44 degrees Celsius. And if we look at precipitation, well, there's a fat 0% chance of rain. Okay, that's good. It'd be nice to know if it was just going to rain all of a sudden. Winds about 8 miles an hour. Not bad, not bad. And we see here that there's really no cloud cover. Humidity is 37%, which is pretty heavy from my limited knowledge of it. And that is the current weather conditions. But that's right now. As we see here, when we get to 11 a.m. or if we get to Thursday, it's going to be 62 degrees or 44. Sorry, low of 44. That's not Celsius. It looks like there's going to be 56% humidity, 14 miles per hour wind, and it's going to be partly cloudy. So you're seeing that the weather is going to change from Sunday, which is now, to Thursday. Okay, great. Well, what about the climate? So what if I type in climate, Thousand Oaks, and I put in March? Let's see what it tells us. Okay, so now it's giving us our weather averages. Now this isn't perfect, but around March in California, you'd expect it to be around 66 degrees Fahrenheit at its highest point, 47 during its lowest point. It's going to rain about 5 days. So you're seeing that climate is what you expect. So this is what we expect Thousand Oaks to be like in March, because it's more of an average. But it is not the weather. You can't confuse weather and climate, because weather is right now, climate is average, what you expect at a certain point in time. So that's the difference between weather and climate. Now, there's something called climate change. And climate change is a term that is kind of thrown around a lot. But if you look at things that have been going on the past couple of years, we're seeing that the averages for certain areas are the weather that's been happening is quite a bit from the expected climate. So climate change is drastic differences. I mean, maybe drastic isn't the best way to put it, but it's more significant differences in weather conditions that is far from the area's average. So to give you an example, we have a couple of years ago, I believe it was in 2018, we had the polar vortex. Polar vortex caused freezing temperatures, actually sub-freezing temperatures, caused sub-freezing temperatures in parts of the country. This was really bad, if you remember. I believe in Illinois, I remember reading in some of the states, it was like minus 10 degrees or even colder. And of course, we know that now, I mean, these are just a couple examples. In 2021, there was the Texas deep freeze. That's Texas deep freeze. that caused the massive power outages. In fact, let's go ahead and look at some of these things here, just because it's interesting. So 2018 polar vortex Chicago. So let's look at this. Wow. So it looks like it was 21 below on Wednesday morning during a certain, and this was January 30th, 2019. So I'm just going to put polar vortex Chicago. Let's see here. I just remember reading about Chicago, about how frigid it was getting there. Yeah, 2 weeks of high temperatures below freezing and 30 inches of snow since January 25th. Oh my gosh. Oh, why not? Let's watch a video. Okay. Well, fascinating.
27.
Oh, here we go.
Craving an adventure bit?
Huh?
Now you can go from watching it all, doing it all.
That doesn't look like our
Introducing
video.
the all-new, fiercely reimagined Nissan Rogue. Look out, outdoors.
Okay, watch
Go
out
inside.
outdoors. The Nissan Rogue is coming for you.
Go Rogue. Or wherever adventure takes you.
All right, well, if any of you
Feeling the chills, certainly. We are here in Chicago, and to blame the polar vortex. This is a cold pocket of air near the poles. Some of this cold air has been sent southward, well to the south, impacting parts of the Midwest and the Great Lakes. And this has been a long duration cold snap for us. We have had days in a row with our temperatures.
All right, I was kind of hoping for the one on the bottom, whatever this is going on, but all right, so you get the idea. Very cold.
What was that? I think I missed that. So yeah, you're right.
Yeah, okay.
It's been
all right, we're done here. Yeah. Ooh, okay. I should have just turned to YouTube in the first place instead of dealing with these. Wow. Yeah, in case you're curious, that's not how Chicago looks commonly, even during the winter. Wow. Minus 50 degrees Fahrenheit. Unheard of. Wow. Yeah, just imagine waking up to that. Huh. That was a super soaker, in case you all were curious. It was so cold that the moment you sprayed the water, it just turned to ice. It's crazy. Yeah, that is crazy. Yeah, so if you find this interesting, you can, I'm sure, watch more videos on it, but it's just crazy how, yeah, this absolutely crazy how we have something that normally is centered in the polar regions, and it came and hit some parts of the US. I'm not going to show you anything on the Texas deep freeze. That's fairly recent, but you can go ahead and check that out if you like. Yeah, so it's important to know with climate change, it doesn't necessarily mean increases in temperature, even though that's part of it. It just means that more often that the weather conditions are different from the average climate. So what that does is it's going to change the climate if the weather conditions routinely are different than what you expect. Like I know that the climate of California has changed quite a bit just because of so many years we've had with virtually no rain. Now, there's something called greenhouse gases, and it's important that we kind of talk about those. And greenhouse gases, it is a layer of gases in the troposphere. And I don't know how much we'll be talking about it this year, but there are different layers of the atmosphere. And the layer that we live in that goes about, I'd say, 50 kilometers up, if my memory is correct, is the troposphere, and that's the layer that has all the weather. We won't, unless you decide that you're going to go on a military spy jet or straight to outer space, you won't ever see anything outside the troposphere. So greenhouse gases are a collection of gases at the upper end of the troposphere, and it includes carbon dioxide or CO2, methane, water vapor. Nitrogen compounds. Believe it or not, I'm pretty sure that water vapor is the most prominent gas in the greenhouse layer. Methane is very potent as well. CO2 gets all the attention, but methane is also a very potent greenhouse gas, and that is emitted in large quantities by cows. And this leads into something called the greenhouse effect. And it's too bad we can't talk more about environmental science this year. I have a feeling I programmed in, if I didn't, I probably will. I programmed in some parts on environmental science. And if I did, which I'm pretty sure I did, then we will talk more about this. But the greenhouse effect is, think of the greenhouse layer as like a blanket. And what it does is that this big blanket, the greenhouse layer, it keeps in heat. When the sun rays strike the earth, what's going to happen is that some of it's going to be absorbed by the earth, and the rest of it's going to be reflected back into the atmosphere. Think of it like when light hits a mirror. If you touch the mirror, some of the part where the light hits is going to be warm, but you don't look at a mirror that's in direct view of the sun, because you'll see that it's reflecting back lots of the sunlight as well. Well, that's how the greenhouse effect works, is that when that light bounces back, the greenhouse layer returns it back to the surface, like it's playing tennis with it. So the greenhouse effect is the greenhouse layer returns heat to the surface raising the temperature. Yeah, it returns heat to the surface, raising the temperature. Think of the greenhouse layer as a blanket. And the thicker the blanket is, the more heat it keeps in. So you do need a layer of greenhouse gases. If you don't have a thick enough layer, then you get another ice age. But if the greenhouse layer gets too thick, then it keeps in too much heat. And of course, what we suspect is that by adding too much CO2 and too much methane, is we've made the greenhouse layer thicker than it is suitable for life or suitable for comfortable life. And that is why we are getting so much hotter and more turbulent weather. Okay, well, we're going to take a short break and then we'll come back and we'll talk about carbon dioxide. All right, so now we're on to carbon dioxide, also known as CO2. And carbon dioxide has gotten a lot of attention in the media, of course, as being the worst thing possible, right? Well, carbon dioxide in itself is not bad. In fact, it is an essential gas that we produce every time we exhale. And plants also need carbon dioxide to grow. Because what they do is that through the photosynthetic pathway, if you remember, is they take carbon dioxide and they turn it into solid sugar. So carbon dioxide is necessary in the environment. The problem is that we're adding too much to it. So carbon dioxide, also known as CO2, that's the chemical abbreviation. It is a atmospheric gas that is created by combusting carbon-based compounds. And yes, we do combust carbon-based compounds. And that's what creates the carbon dioxide. Now we'll talk about the carbon cycle in just a moment. So we're going to talk now about the carbon cycle. So I'm going to draw some ground here. Some trees. Yes, I know you all missed my drawings. Probably saying, Professor, I haven't seen one drawing yet. Well, here you are. Here's a factory. Here's some animals. Straw cow doing this thing. And I think that's it for now. Well, yeah, we'll draw some water. Why not? Okay, now this is called the carbon cycle. And that's because what carbon does is carbon cycles between two forms. So carbon cycles between its gas and solid forms. Now we have a term when we talk about these cycles, it's called a source. And carbon sources are all the things these are all the things that add CO2 to the atmosphere. And a carbon sink, I'm not going to write carbon in front of it, I'll just put down sink. A carbon sink removes CO2 from the atmosphere. That looks a little better. Okay, let me draw some more. I'm just going to draw some more plants here. Okay, now let's talk first about the carbon sources, things that add carbon dioxide to the atmosphere. Well, first is going to be respiration. Animal respiration puts carbon dioxide into the atmosphere. Factories and other machines. So with this here, we're just going to put down any kind of machine. So this includes cars, factories, trucks, leaf blowers. I mean, you name it. Anything that runs on combusting fossil fuels, we'll just call a machine. Okay. Also, fires. Yeah, I know. Sorry, trees. So fires are other ways that carbon dioxide is put into the atmosphere. We can't forget about sources of water too. Carbon dioxide also emanates from the water. But here's the thing. Well, actually, let me talk about the carbon sinks next. Now, carbon sinks is anything that takes carbon out of the atmosphere. Plants via photosynthesis. And also bodies of water also taking CO2. Now, normally, this is a pretty balanced cycle because there's so many plants on Earth. There's so many plants that whatever carbon dioxide is put into the atmosphere was taken out by plants. It was a pretty balanced process. And of course, fires contribute quite a bit of CO2, volcanoes as well, but other than that, it pretty much balances out. The problem is this, machines. Because the problem is that fossil fuel combustion, the problem is that fossils, including oil and coal, that otherwise would never be disturbed, are converted into CO2. So underneath the soil, there are fossil fuels in the forms of coal, in the forms of oil. And these normally are things that would never be disturbed. They're underground. They're not bothering anyone. They exist as a carbon, as just a sink. But the problem is that we're taking these fossil fuels and we are combusting them. So the end result is that we're adding these carbon fossils, we're turning them from their solid form to their gaseous form. So what we're doing is that we're adding carbon dioxide to the atmosphere every time we burn these fossil fuels. Now, you might be asking, well, what is the impact of that? Well, we're seeing that as we keep on burning fossil fuels, as we keep on combusting fossil fuels, it is adding more carbon dioxide to the atmosphere. And we know there's a positive correlation between the amount of carbon dioxide put into the atmosphere and the impact of climate change. So there's really only a couple things we can do. One, we can stop burning as many fossil fuels, switching from, for example, coal-based power plants to nuclear um, or other renewable energy. We can switch motor vehicles to more electric or hybrid. We could just rely more on alternative energy in general. It's probably not going to happen as fast as we want it to. Other option is plant more trees and plants. Well, okay, that's fine, but we're too busy developing things on said land. So the other options are rather dystopian. One is to build giant machines that convert carbon dioxide to solid carbon, called artificial photosynthesis. Um, yeah, they're even researching bioengineering trees and plants to convert more carbon dioxide to solid carbon. So yeah, it's starting to seem like we aren't going to change people, so we can only change the environment um, to mitigate the damage we're doing to it. But the number one best option is just stop burning as many fossil fuels. But I don't see that. I don't see that happening. I don't see a dramatic change like that happening for decades. Now you might be asking, well, what is the impact of me on the environment? And there is a measurement for that called an ecological footprint. What it is that it's a test. It is a measurement of environmental impact and the unit measured is number of Earths. And if you want to take this test yourself, let me go ahead and show you how to take it. I've taken it a lot. But you go to footprintcalculator.org. So footprintcalculator.org. And, okay, whatever. And you click here. And it actually lets you take a survey that will tell you approximately your ecological footprint. And I'm not going to, well, I'm not going to do it, but I'll just show you how it, what happens when you take this test. Okay. Your email is not required to view your results, but we'd love to stay in touch. Skip to view my results. All right, so when it says here, your personal Earth overshoot day, that is based on the data you inputted by March 24th, which is actually in a couple days, is you would exceed the amount of resources allotted to you in that you should be using in 1 year. So what it's saying is that if you want to live a sustainable life, well, let's see, I'm trying to say how to put this. So it says here that you require, or me in this case, the resource equivalent of 4.4 Earths. Meaning, if everyone lived like me, we would need 4.4 Earths to provide all the necessary resources. Of course, if you want to live sustainably, you only would need 1 Earth or less. So what this is saying is that by March 21st, based on my lifestyle, this is the day where I would exceed the resources necessary to live a sustainable life. Now, I'm not going to tell you if my actual results are more or less, but this kind of breaks it down to tell you how sustainable your life is. And of course, it says, how do you feel here? So you can feel really guilty. But don't feel guilty. I never had a student get less than 3. One of my students got like a 12, but I think he was really trying. He was going for the gold. He was trying to get as high as possible. But yeah, it's interesting. If you do enjoy this stuff, environmental science would be a great choice for you. It's a very interesting class. All right, well, that is all for the introduction to ecology. Hope you enjoyed this lecture, and pretty soon we'll be having the next one posted. All right, we'll see you soon.